Good morning. It is a beautiful day here in sunny South Florida. Sorry, not sorry for all my friends up north who are experiencing this blizzard-like weather. So today is an exciting day. Today we will be running the Cymatics trainer for the first time. So what I'll do is I'm going to give kind of a basic explanation of how this trainer works, kind of the logic behind it. We'll go through one of the first runs, and then we'll look at the data that it produced, and then finally we'll go ahead and I'll outline what the next steps will be. So first off, about the Cymatics trainer. So I'm using the transfer learning method. And rather than building a new AI from scratch, this would take millions of pictures and hours upon hours, if not days, of processing in order to teach it simply what is a line, what is a circle. So there's open source stuff that's already available. And like I mentioned in another video, I'm using ResNet 18. This brain has already looked at millions of internet photos and is essentially a master at seeing shapes, textures, edges. I simply take this adult brain and snip off its decision-making layer. I tell it to forget like things like dogs and cats and trees or whatever it may be. All we want it to do is look at the data that I provide and is it a cymatic or is it just noise? So the way that this works is you kind of think of it like flashcard tests. So I allow it to look at 80% of the data. So in both folders, it has access to 80%. And it's going through that and it's studying it and it's trying to figure out what's what. The remaining 20%, it does not have a chance to look at. It's never seen the other 20%. And I will then show it one at a time that the remaining 20% as a test. If it gets it right, great. If it gets it wrong, it needs to update its system and then try again. So, and that's what's going on here with these epoch. Basically, it's a flashcard test. It's analyzing all of this data. It's going to then take the remaining 20% and give itself a test. So this is obviously very intense for on the processor. That's why it's nearly crashing my system. It looks like I'm going to have to upgrade to the next size NVIDIA Jetson. This is just the Jetson Nano. So I could see the next level up in my near future. And that's basically kind of how it works. So the AI will look at one of these pictures and say, I think it's a cymatic. And then the script checks the answer and it says, it effectively says, nope, that was noise, adjust your math. So it's doing that over and over again. And when we get a new high score, it'll actually just it'll save that for me. So then you can see here I got a decent, what was the first one, so that's obviously the winner. But then down here you can see I'm starting to get better and better scores. So it's working. It's getting higher scores. So this is going to run through for another minute or so, and then we will get into um, the first run here. So I could go ahead and fast forward this a little so we could get into that. Let's see where we're at here. Okay, there we go. So I believe I lined up the next script right behind it. Let's see here. There we go. So the AI sweep. So what I did for the AI sweep is rather than going through a bunch of different frequencies, I stuck with one frequency, just 13 hertz. I'm going from 13 to 13. You'll see my step size here is going to be just 0. And then I'm just sweeping the amplitude here then. So all I want to do is, like I said, my frequency isn't going to change one bit. I'm just going from where I find the pattern starts and kind of where it ends. And then I'm going to be stepping through again. I think what did I do here? Yeah, half a volt or zero point zero 0.05 of a volt. Um, the wait time is 10 seconds. I kind of wanted it to go fast. And here's the AI confidence threshold that we put in. So it's going to take a picture of anything 85% or above. And this is important to see here because in my noise folder, you'll see it saying it's 100% match right here. We know that this isn't a cymatic, but this has never been trained on a dead system. Right now, the system is not on, so it's never seen this pattern before. So this tells me that I got to go through and grab a bunch of these images and throw it into the noise folder, which we'll get into in a little bit. So I went ahead and I started it, and immediately the rings come up that I talk about in some of the other videos. Again, this is just us below the normal or below the amplitude that's going to cause the pattern to come out. So you'll see here the power level is going to continue to rise by 0.05 volts every 10 seconds. And we should have a pattern starting to form here in just a moment or two. And then what's important is let's keep an eye on the AI match because, again, we're running that algorithm, we're running the AI side of this. And as that pattern starts to emerge, we should expect this number to start rising, and there we go. It's now starting to see some kind of a pattern, and it's saying, "Hey, we got something," and it's dumping this into a separate folder. So we'll allow this to run for a few minutes. Again, we're not changing frequencies. We're just going through the voltage here, just the amplitude, sorry, and we're going to go through. So one of the things that I noticed when I was running this live is when we get into some of the higher amplitudes at 13 hertz, I visually saw some really nice cymatics on the screen, but it wasn't grabbing it. So that tells me that I need to start running this data or this frequency a little bit more on the capture side. And towards the end of the run, I realized that what I'll probably wind up doing is the sorting software that we run. I'm actually going to also link that to this file. So technically speaking, everything that goes into my screenshots folder or snapshots that you see down there in the bottom left, everything that should be going in there should be a cymatic. But since we're still kind of in the training phase of this, I'm going to go ahead and link my sorting software to that. This way, even these images will start to become part of my library that it pulls data from. So here's where I was talking about. We get into what appears to be a nice cymatic, but it's not grabbing it. So that's where the sorting software will be helpful when I use it in this folder. Actually, it's not even capturing a picture here. So it's thinking this is all noise, so it's not capturing noise stuff. So I'll come back in this area with the sorting stuff and reteach it the cymatic. So we'll go ahead and fast forward a little bit into the the sorting stuff. All right, so this is the folder that I used. Oh, I gotta wait a second. So this is the snapshot folder here. This is where all the data is going to be going that we collect using AI. So here you see that one image I talked about earlier that I'm going to have to teach it is obviously a bad one. And like I said, I'm just going to link my sorting software to this. So as I run through these pictures, they're going to go into one of three buckets this time. One bucket's going to be noise, one is going to be cymatic, and one is going to be cymatic and keep, which means that that's going to go into like a final folder that I'll start using as basically my product or my final data. So I don't mind putting some of these partial cymatics into the cymatic program. Again, I want to have a large data set. Everything in the cymatics folder doesn't have to be perfect, but I want it to be relatively close. But when I get like a really beautiful one, I don't want to have to go into that cymatics folder to find it. I want to save that to a special place. So that'll be the script that I write this morning. Will be noise, cymatic, and cymatics keep. So yeah, this worked out pretty good. I've got some more teaching to do, obviously, but But yeah, this was a fun exercise. So what I'm going to wind up doing now is I'll be going through and doing some short videos now where I'll pick one small frequency band, note the parameters, what frequency I'm at, and I'll just run through it real quick and make it just nice and tight, neat little packages that'll be a minute or less. So I'll get on that now. Otherwise, it's been great, and we'll talk soon.